All right, 3.6, graphing linear equations in slope-intercept form. So starting off, we have slope. Slope is a big deal. We want to know what slope is. Slope, the variable that's almost always used for slope, is m. We think about it as being rise over run. Okay, rise, you could change and you could say that that's the change in y, right? How much does it change up and down? And then run is left to right. How much does it change left to right? And we have this formula here for if we have 2 points, right? Here's our points x1, y1, x2, and y2. We do the y's subtracted on top and the x's subtracted on bottom. We want to think about when will the slope be positive and when will the slope be negative, right? This is the same thing as asking when will the function be increasing and when will the function be decreasing. All right, this is the same exact thing. Increasing and decreasing, positive and negative slopes, those are meaning the same thing. So increasing, we know that's whenever it's going uphill. Decreasing, we know that's whenever it's going downhill. All right, remember back to what we were doing whenever we were doing increasing, decreasing, positive, and negative. Increasing is a positive slope. Decreasing is a negative slope. All right, example 22. We want to look at this line. Is this line going uphill or downhill? It is going downhill, so it's decreasing. All right. Finding their slope here, well, let's start off at this point right here. And whenever they have the graph, I just like to count. They have their arrows there. I'm going to draw little swoops on there. We do rise over run. And I'm going to try to see how far does it rise. Well, it doesn't actually rise, it goes down. So 1, 2, 3, 4. And I'm going to say this is -4. And then how far does it run? It runs 2 spots. So this is going to be -2 whenever I simplify that. Now we could see that there's also another point on here that I could have used, this point right there. If I were to use it, I would go down 2 and write 1, which would also give me -2. Okay. A lot of the times you want to find 2 points that are perfectly on the grid, like how these are perfectly on the grid, and you normally want them to be close together. All right. So a lot of times you want to do it like how I did the green one, where they're really close together. It just saves a little bit of work. All right. So our slope, we'll say m equals -2, right? It's a negative slope and it is decreasing. All right. Next up, find the slope from the table. Now, it does not matter which 2 points you pick, but you have to pick 2 and you have to stick with them. I'm going to pick the first 2 points. I'm going to rewrite them as points just so that we can see that. We'd have 5, -2, and 6, 0. X, Y, X, Y. My slope, m, if you remember the formula, it's y2 minus y1. Okay, it doesn't necessarily matter which point you describe as 2 and 1. A lot of times I describe it as the second point is 2 and the first point is 1. That just kind of makes sense to me. So I do y minus y. So I start off with my second point here, 0, and then minus, and then I have a -2. Now I go to my x's. 6 minus 5. The rest of the problem is just simplifying. So 0 minus -2 is going to be a +2. 6 minus 5 is 1, and we can write that as just a plain old 2. So our slope m equals 2, and this would be an increasing line, an increasing function. All right, slope-intercept form. A linear equation written in the form y equals mx plus b is in slope-intercept form. The slope is m, and the y-intercept is b. A linear equation written in the form y equals 0x plus b, or y equals b, right? This is the same thing as what was in our yesterday's notes, is a constant function. The graph of a constant function is a horizontal line. So here we want to find the slope and the y-intercept of each. Let's start off with this one right here. The slope m is going to be equal to whatever is in front of the x. It's 5. If you include the x there, it is wrong. The slope is not x. The slope is 5. The slope is not 5x. The slope is 5. And then b, the y-intercept, would be -1 here. Next up, let's rearrange this equation so that it is in slope-intercept form, so that it is in the y equals mx plus b form. I'm going to subtract my x to the right, so I'm going to have -y equals -x plus 9. And now I can't have a negative y, I need a positive y, so it's going to be y equals x minus 9, right? So I multiplied everything by a -1. Now I can see really easily, my slope m is whatever's in front of my x, it's a 1. And then my b would be -9. Next up, y equals -3. Well, let's rewrite this as y equals 0x minus 3. There I can see, well, my slope m is 0, my y-intercept b is -3, right? And that's a horizontal line. Lastly, we have y equals 7x, and I'm going to put a plus 0 there on the end. So my m is 7, and my b is 0. All right. Looking here, we want to find our y-intercept and our slope. Well, this one, we're not going to actually find our y-intercept. We're going to skip the y-intercept. It's not a very good problem for that. Let's find our slope, though. We don't really care which ones we pick for our slope, so I'm just going to pick those two. So I'm going to take y2 minus y1, so it'll be 1 minus 0 over x2 minus x1, 1 minus -2, right? In my head, I put these as points, so this was -2, 0, and 1, 1. And I did my y minus y and x minus x. Here on top, it turns into a 1. On bottom, it would turn into a 3. So m equals 1/3. And we skip the y-intercept on that one. Next up, those are all the exact same thing, right? The y is constant, right? A constant linear equation is a horizontal line. This one's going to actually be y equals 3. From that, it should be really easy to see that the slope m is going to be 0, right? Because this is y equals 0x plus 3, and b equals 3. All right, let's scroll down and look at the next one. Our slope. I want to find a point. Here's a good point. And the other point that's listed is a good point. So I'm going to have to find my m using that. I'm going to do rise over run. We know this is a decreasing function. This is a decreasing function, so I'm going to be going down 1, 2, 3, 4. So down 4 and over 1, 2, 3. Now for my y-intercept b, we're just going to have to kind of guesstimate there. It looks like it would happen right around, like, I don't know, 1/3 maybe. We'll say 1/3. Next up, here's a good point. And actually, there's another good point right next to it. So my slope m, I'm going to go up, so that makes it positive, up 1, and then over 1. So this is just plain old 1, a slope of 1. B, my y-intercept, is at 2. All right, and next up, oh, that is it. All right, that is slope and y-intercept. I hope you do well on the homework.